Okay, today we're going to continue with our discussion about finding a missing dimension in a volume formula. So just like we did in our last video where we were given the volume, and in that case, a cone or a cylinder's radius, we had to find the height. Today we're going to again be given the volume, but this time we're going to be given the height in the cone and cylinder and look for the radius. Or we're going to be given the volume in a sphere and again look for the radius. It's going to be those same steps with one little additional thing at the end, and we'll get to that in a second. So you'll notice this screen looks very similar in that we're going to start with the formula. We're going to substitute in what we are given into the appropriate variables of the formula, and then we're going to solve for the remaining value, and that's where that extra step to find the radius and or diameter will come in at the end. So let's take a look at this pineapple juice can, this cylinder. The can holds 169.65 inches cubed of juice. Before I go any further in the problem, I see those units. Boy, is that important, because without even the word volume, I know that's the volume because of the units. It has cubic units, so the 169.65 is the volume, and we'll in a moment take the V spot. If the can is 6 inches high, that is the height, that is the H. What is the diameter of the can? Now I'm going to have to worry about that diameter at the end, but let's get to that in a second. Again, always rounding to the 10th. First thing I'm going to do is write my formula with all the variables in there, that the volume of a cylinder is pi times the radius squared times the height. I'm going to go back to my problem, remembering that the 169.65 is the volume, so it's going to take the V spot. And the 6 is going to take the H spot. And we are looking for the radius, which, will eventually give us the diameter in the end. I'm going to wrap, again, commutative property of multiplication. I can change the order, and 6 times pi can come out to the front. I am going to divide both sides by that product. And again, just like the last time, when I go to my calculator and I take 169.65 and I'm going to divide it by parentheses 6 times pi. Make sure the parentheses are in there. You're dividing by the whole product, so you want to do that first. So 169.65, hit your division button, your parenthesis, 6 times pi, your end parenthesis, and hit equals, and you should be seeing the number 9. But that doesn't equal the radius. That equals the radius squared. Here is that last step I kind of mentioned, that we can't just go on with our 9 and think that's the radius. We have to undoing squaring. And this goes kind of back to the idea of when we did Pythagorean theorem, and we would have that c squared, and we would have to take the square root. So the opposite of squaring is taking the square root. So if I take my calculator and take the square root of 9, and the square root button is usually on in blue on our calculators at school over the x squared button. So you're going to hit the second function and the x squared, and that'll give you the square root. If you're using your phone, you're going to turn your phone to the side, and you should see a square root button, and you would hit that button, put the 9, and when you take the square root of 9, it's 3. It's not half of 9. It's what number times itself gives you 9. 3 times 3 gives you 9, so the square root of 9 is 3. So the radius is about 3 inches. But the problem asks for the diameter. Well, the radius is the short guy. To get the diameter, you have to multiply it by 2, and the diameter of the can would be 6 inches. So again, write your formula. Substitute in what you know. Kind of clean up the math and solve for the variable that is still there. And in this case, because the radius is being squared, to get it at the end, we have to take the square root. If you're given the radius and they're looking for the diameter, you multiply by 2 to get the bigger guy, which in case would be 6 inches. Now notice your answer is not squared or cubed because it is a straight distance. It's how far across the can from edge to edge, and that wouldn't be square inches. That would just be measured with a ruler. It would be straight units, and it would be straight inches. Again, I just want to remind you to make sure that when you're doing a dividing, if you still have the pi in there, to make sure you use the parentheses. Okay, so let's try one. This time it's going to be a cone. Happy wants to make a cone-shaped hat with a volume of 250 inches cubed. The hat is going to need to be 5 inches tall. What is the approximate radius of the hat? We're going to round to the nearest tenth. So right now I want you to think about what formula would you use for the volume of a cone, and we're going to write that down. So it is the same as the cylinder, but we need to divide by 3, which is the same thing as multiplying by 1/3. Okay, now we're ready to substitute. The 250 goes in the V spot, and the 5 goes in the H spot because it's the height. We're going to kind of clean up the math here. So we're going to take the 5 divided by 3, multiply it by pi. So this time I'm going to show you you can approximate. You don't have to leave the pi in there. So if you take 5 divided by 3, multiply it by the pi, it's about 5.24. We want to solve for the radius. This is a one-step equation, so the opposite of multiplying would be to divide, just like we did last time. I'm going to pick up my calculator and take 250 divided by 5.24. So this time, instead of having the pi in there, we did the approximation first, which is a fine way to go as well. In my calculator, the radius squared is about 41.03. That is not the radius of the hat. It's the radius squared. In order to solve, we have to undo the squaring, which would be to take the square root. So in our calculator, again, the ones in school, you would be hitting that blue second function and the x squared button to get the square root of 41.03. And if you use your phone calculator, there should be a square root button on there. The square root of 41.03, what number times itself is about 41.03? And you should see it's about 6.4. That 6.4 is the radius. Let's just go up and see what we wanted up here. We wanted the radius, so we just need to put the units in, and it would be 6.4 inches. So we've done a cylinder, and we've done a cone. We're now going to bring back a shape that we haven't worked with in a while, and that's going to be our sphere. Now the sphere's formula does not have a height in it, but it has a radius cubed. So that's going to be a little bit interesting at the end, but it's going to be the same start. We have a snowball. It's a sphere. Its volume is 65.45, and that's all we know. What's the radius? So our blank formula with our variables is the volume of a sphere equals 4/3 pi r cubed. I'm going to take the 65.45, and it's going to take the V spot. Now, if I go into my calculator and take 4 divided by 3 and multiply by pi, you're going to see this number show up. And you'll get very comfortable with this number in a sphere because it's always the 4/3 times pi. It's about 4 point. And you notice I'm holding out 3 places just to kind of keep it accurate here as best I can. Now, to solve this one-step equation, I'm going to divide both sides by the 4.189, and I pick up my calculator and I take 65.45 and I divide it by 4.189, and in the calculator I see 15.625. Now, 24. Now I know I said round to the nearest tenth. I'm going to do that at the end. I'm trying to keep out as many places right now. I am not done. That is not the radius of the snowball. That is the radius cubed. Now to undo cubing, I need to not take a square root. I need to take a cubed root, which again we also did way back in the fall. Now on your calculator, again, I'm going to use the one from school, but you need a root that has a 3 up here in the index. And on our calculators in school, you would first put 3. You would then hit the second button and the TP, which would give you what is called the root button, any root. That X means you could take the third root, the fourth root, the fifth root. So since I want the third root, I want to undo cubing, I would put a 3 in the calculator. I'd hit the second function and the TP, and then I'd put the 15.624 in and hit equals, and I'll see 2.5, and the radius of the snowball would be about 2.5 feet. Going to be quite a big snowman there. So again, this depends on your calculator. But again, on your phone, if you turn it sideways, there could very well just be a third root. So you look at the root symbol, and in that little V of the root symbol, if there's a 3, that's the button you need to use. What you might want to do is try this on your calculator. Try to take the third root of 15.624 and see if you get the 2.5 to make sure you're doing it right in the calculator. If you need to pause the video to do that, please do. But we're going to go on and do a couple more with a sphere or a hemisphere. So here comes a beach ball. Its volume is 381.7 feet cubed. Didn't even need the word volume because I can see that it's a volume by its units. Look at that. And we need what's the radius of the ball. Remember, there's no height in the formula for a sphere. So once I'm given the volume, I can find the radius. I'm going to get my volume formula for a sphere. And I'm going to take 4 divided by 3 and multiply it by pi, and this is going to look familiar because we're doing that same math again that we did on the last one. That right there, the 4.189 is 4/3 times pi, and that always exists inside of a sphere formula. Now I want to solve for r to the third, so the opposite of multiplying would be to divide both sides by that 4.189. I'm going to pick up my calculator. 381.7 divided by the 4.189 is about 91.12. And again, I'm not rounding to the 10th. I'm keeping 2, 3 places so that I can kind of keep some accuracy in here. That is not the radius of the beach ball. That is the radius cubed. So I need to take the third root of 91.12. What number times itself again gives me about 91.12. And when you take the cubed root of 91.12, it's about 4.5. So the radius, and they did want the radius, of the beach ball is about 4.5 feet. I'm just holding for a second. If you want to pause, take a look at that, check it in your calculator. That is how we find the missing radius of a sphere. Okay, the last one before I kind of give you a challenger problem at the end is what if it was a hemisphere? So this time it's half the sphere, and here's the volume of half that sphere. So I'm going to get my formula, and I like to just use the formula, and instead of doing 4/3, do 2/3, and that is your hemisphere formula. So the 575.2 again is going to take the V spot. Now when you take your calculator and take 2 divided by 3 times pi, you're going to get, a different number this time, which is half of the one we just noticed, the 4.189 for the sphere. So this will always show up in a hemisphere problem. Now to get the radius cubed by itself, the opposite of multiplying by 2.094 would be to divide both sides by the 2.094. It's kind of like we're solving a one-step equation with an added step at the end. So I'm going to divide both sides by 2.094. I'm going to take the 575.2, divide it by 2.094, and in my calculator I'm going to see 274.69. That's not the radius of the bowl. That's the radius cubed. So to undo the third power, I have to take the third root. So I'm going to take the third root of 274.69. I would pause the video right now, take your calculator and try to take the third root of 274.69, and then we'll check it. Okay, now that you're back, did you see in the calculator it's about 6.5 inches? Again, it's straight units because you're looking for the radius of the bowl. Now, when we go back to the problem, notice they want diameter. Well, that's no big deal. I just take my radius, which is the smaller distance in the circle, multiply it by 2, and it is 13 inches across the whole bowl through the center. Any point in time, if you need to pause and take a look and think about this, please do. Okay, the last thing I'm going to end with is kind of a challenger problem. So if this one kind of perplexes you, and you've been okay up to now, you are good. You are more than good. But I thought just for the folks that are kind of all over this, let me give you a real world problem dealing with a pipe, and give it a go. And like I said, if this is the only one you're having trouble with understanding, you are in good shape. And for the rest of you, you could kind of think of this as a challenger. So imagine that there is a pipe, and it is 12-inch long. It's made of copper. And the copper that makes the pipe, now what I mean is, the pipe has a hole in it. So, this pipe right here is 1.5 inches cubed of copper. The outside diameter, so if you go from the outside of this edge of the pipe through the center to the other side, it would be 0.6 inches. It's a very small pipe. What is the inside diameter? So I want to know sort of the diameter of the hole. I want to know from the center of the circle to the inner edge of the pipe. And we're going to do it to the nearest 100. So I know I'm going to start by finding the volume as if it didn't have a hole. So I'm going to find it without the hole. So I have 12-inch copper pipe. And I know that the outside diameter is 0.6. So I'm going to use the volume formula of a cylinder. I'm going to put the 12 inches in for the height. And I'm going to put the 0.3, half of the diameter, in for the radius. I'm going to take 0.3 and square it in the calculator. I'm going to multiply it by 12. And I'm going to multiply by pi. And the volume, if it did not have a hole, if it was solid, in other words, would be 3.4 cubic inches. Now that would be if it didn't have a hole. Now I'm trying to find sort of what's going on with the hole, and they gave me the hula hoop. They gave me the ring as 1.5. So if I take the 3.4, which is the solid cylinder pipe, and subtract out the 1.5, which would be the ring, that'll give me how much space, how much volume the hole takes up. So I'm going to take the 3.4 and subtract the 1.5, and the hole, imagine if you could measure the cylinder it's just air that's in there, the air would have 1.9 inches cubed. And what I want to do is find the diameter. I'm going to start with the radius of the hole of the air inside. So I have the volume and I have the height, but now I need the radius. So now I'm doing the inside diameter, which is we're talking about the volume of the air inside, basically. So there is my cylinder. My volume is the 1.9. My height is still the 12. And I'm looking to find what is the radius of the hole. I'm going to take the 12 times the pi. It's about 37.699. I'm just keeping a bunch of places here while I'm working. I'm going to divide both sides by that 37.699. 1.9 divided by 37.699 gives me about 0.0504, and that's the radius squared. I'm going to take the square root of the 0.0504 in the calculator, and the radius of the air of the inside would be about 0.22 inches. That's the radius. The problem asked me for the diameter, so I'm going to double that. The radius is the short guy, the diameter is the big guy. So to go from the radius to the diameter, you multiply by 2, and the diameter would be 0.44 inches. So if just went through that and you're like, oh yeah, I got that. Congratulations, because that is a real world volume, interesting problem. And if you had any trouble with it, if you want to pause and see if you can figure it out, go for it. But like I said, if you have understood up to including that hemisphere problem, you're really understanding what's going on.